Hello, this is Mrs. Ward, and I am going to go over the classwork for section 7.3, multivariable linear systems. So what's happening in this section, instead of just having two unknowns and two equations, we are going to up that a little bit, and we are going to start off with three unknowns and three equations. So number 4 just wants me to determine whether each order triple, I should say order triple, is a solution to the system. So to figure this out, I'm going to substitute in the numbers for x, y, and z. If it works, then it's a solution, but it has to work for all three equations. And if it doesn't work, then it's not a solution. So let's start with A. I'm going to start by putting A into the first equation. So this would be my x, my y, and my z. So I'm going to have negative 4 times x, which is negative 2, minus, and then negative 2 for y, minus 8, and then positive 2 for z. And that should equal negative 6. So this will be 8 plus 4 minus 16. I want to see if that's equal to negative 6, and that's negative 6 is equal to negative 6. So it works for the first equation. The second equation is y, which is, I'll switch colors for the second equation. The second equation is y, which is negative 2, plus z, which is 2. I'm trying to see if that equals 0. 0 is equal to 0, so that one checks. Now I'm going to put it into the third equation. So here's the third equation. I'm going to do 4 times x, which is negative 2, minus 7 times y, which is negative 2. There's no place to put in the z. I'm seeing if that's equal to 6. So this is negative 8 plus 14. So 6 is equal to 6. So that works. Since it works for all three equations, I am going to say yes for A. Now let's do B. We'll go the same colors. So doing the first equation, I'm going to do negative 4 times negative 33 over 2 minus y, which is negative 10, minus 8z, which is 10, and I'm trying to see if that's equal to negative 6. When I multiply, I'm going to have 66 plus 10 minus 80 is equal to negative 6, and I get negative 4 is equal to negative 6. So that's not true. As soon as it doesn't work for the first equation, I'm going to stop. There's no need for me to check the other equations. It doesn't work, so I'm done. So now I'm going to do C, and I'm going to put that on another piece of paper, so give me a second. Okay, I just need a little bit more room. So now I'm going to do C. I'm going to type, substitute in the 1/8. So negative 4 times 1/8 minus y, which is negative 1/2, minus 8z, which is 1/2. And I'm trying to see if that's equal to negative 6. So when I do this, I get negative 1/2 plus 1/2 minus 4 is equal to negative 6. So I end up with negative 4 is equal to negative 6. So that's a no, so I stop. I don't have to do anything else. Because if it doesn't work for one equation, it doesn't matter if it works for the other two. It has to work for all three. Last one I'm going to check is D. So I'm going to do negative 4 times x, which is negative 11 over 2, minus y, which is negative 4, minus 8z, which is positive 4, and I'm trying to see if that's equal to negative 6. When I do that, I have 22 plus 4 minus 32 is equal to negative 6. And I do get negative 6, whoopsie, is equal to negative 6. So I'm going to continue on to the next one, which I believe we did in blue. So now I'm going to do y, which is negative 10, plus z, which is 10. I want to see if that's equal to 0. So I get 0 is equal to 0. So it does work for the second equation. And now I'm going to check for the third and final equation. So the third equation would be 4x. So 4 times negative 11 over 2 minus 7y, which is negative 4. And I want to see if that's equal to a positive 6. So when I do that, I get negative 22 plus positive 28. So I do get 6 is equal to 6. Since it worked for all three equations, then I'm going to say that, yes, this is a solution. So A and D were solutions. C and B were not solutions. Okay, the next one, it says use back substitution. So remember when I have these stair steps, this is in row echelon form. It is not in reduced row echelon form, but it is row echelon form, which means I can just simply go ahead and back substitute in. So I'm going to take this 2 and put it in for the z here and solve for y. So I'm going to have y plus 2 is equal to 12. Subtract 2 from both sides, and I get y is equal to 10. Now I'm putting that 2 back in for this z, and I am going to put this 10 back in for the y, and I'm going to solve for x. So when I do that, I am going to have 2x plus y, which we just said was 10, minus 3z, which is 2, and I said it is equal to 10. So I'm going to have 2x, and then this will be 10 minus 6 is equal to 10. So that's 2x plus 4 is equal to 10, 2x is equal to 6, x is equal to 3. So now I'm going to finalize my answer by writing that order triplet in the form of x, y, and z. So it's going to be 3, 10, and 2. And that is my final answer. Okay, let's do the next one. The next one wants me to perform the row operation and write the equivalent system. So it's saying add equation 1 to equation 2. So I'm adding x minus 2y plus 3z is equal to 5. That's equation 1. And I'm adding it to equation 2, which is negative x plus 3y minus 5z is equal to 4. I'm just adding those so the x's will equal 0. Then I'm going to have positive y minus 2z is equal to 9. Then the equivalent system, I'm going to keep, since it said to add equation 1 to equation 2, I'm going to make this my new equation 2. So I'm going to write x minus 2y plus 3z is equal to 5. Putting this in for my equation 2, and then copying down my third equation. And that's my equivalent system. Okay, number 12 wants me to add negative 2 times equation 1 to equation 3. So I'm looking at equation 1. This equation here, I'm going to multiply everything by negative 2. So that's going to be negative 2x plus 4y minus 6z is equal to negative 10. That's multiplying this whole thing by negative 2, and I have to distribute it to everything. I'm adding it to equation 3, which is 2x minus 3z is equal to 0. If you notice, I'm taking great care in forming columns. Here, let's highlight. I want to form a column for my x's, a column for my y's, and a column for my z's, and then finally a column for my answers. And I'm doing that on purpose so that when I go to add, I'm adding like terms. And if I'm missing an x, a y, or z or something like that, I'm going to skip the space. So I line up in these columns. So this is going to be 0. This will be 4y minus 9z is equal to negative 10. And since it said to put it, add it to equation 3, I'm going to make that my new equation 3, which means my first equation is going to stay the same. My second equation is going to stay the same. And now my third equation is going to be that 4y, which notice it didn't have a y before, but when I added it, I added that y to it, is equal to negative 10. And that's my equivalent system. And it said, question 12 said, what did this accomplish? It made it so that the x was eliminated. And when we go to solve these, we are going to follow in a certain pattern. And this is the pattern that was on your note sheet, where we're going to eliminate we're going to combine row 1 and row 2 to eliminate the x. And then we're going to do row 1 and row 3 to eliminate the x. And we're going to just follow this pattern to put, and if I follow this pattern, I'm going to solve it so that it's in reduced row echelon, which means I'll know my x, I'll know my y, and I'll know my z, and I don't have to do the back substituting. So number 15, I'm going to follow this pattern. I'm going to do row 1 and row 2 to eliminate the x. So when I look at this, I think I want to multiply, and I write myself notes. Here's row 1, row 2, row 3. And over here, I'm going to scooch this guy out of the way for a second. I'm going to write myself notes. In order to eliminate this x in row 2, I'm going to have to multiply row 1 by a negative 2. So I'm going to take negative 2 times row 1, and I'm going to distribute that. So it's negative 2x minus 2y minus 2z is equal to negative 12. I'm copying down row 2, which is 2x minus y plus z is equal to 3. When I add, I have negative 3y minus z is equal to negative 9. So if I'm looking at this chart, I did row 1 and row 2 to eliminate the x, and it's telling me that it's a good idea to put that as my new row 2. So I'm going to do that, and I'm going to sort of have a running tally over here. So I'm leaving row 1 alone right now. That's going to be my new row 2. And then if I'm following this chart, I'm going to do row 1 and row 3 to eliminate the x, and that's going to be my new row 3. So I'm going to do that now. So I'm looking at row 1 and row 3. What do I have to multiply this x by in order to eliminate this x? And I say negative 3. So this is like elimination that we just did. I'm going to take negative 3 times row 1. I'm going to multiply negative 3 times all of that. So negative 3x minus 3y minus 3z is equal to negative 18. That's what happens when I multiply this whole thing by a negative 3. Now I'm copying down row 3. 3x minus z is equal to 0. When I combine my like term, or when I add my columns, my x's will equal 0. I'm going to have negative 3y minus 4z is equal to negative 18. And if I'm following this chart, that tells me that's my new row 3. So I'm going to put that in my row 3. So that's negative 3y minus 4z is equal to negative 18. So right now I have this stepping point where I've done the first, oh, I didn't want to erase that. I've done the first couple things, and I have what I'm left with at this point is I should have eliminated the x in the second equation and the third equation. Then following this pattern, once I do that, it tells me to combine row 2 and row 3 to eliminate the y. So looking at row 2 and row 3, row 2, whoopsie, bad highlighting choice. Row 2 and row 3, I want to eliminate the y. So it looks like I could just multiply one of them by a negative and leave the other one alone. So let's say I take negative row 2, and over here's my little work area. So I'm going to take negative row 2, so that's going to make that positive 3y, plus a positive z, and that's going to equal positive 9, because they were all negative. If I switch the signs, they're all going to be positive. Copy down row 3, so this will be negative 3y minus 4z is equal to negative 18. And when I do that, the y's will go away. I'll have negative 3z is equal to negative 9. Well, at this point here, I want to know what z is. And at this point here, as soon as I have z is equal to something, I'm going to divide both sides, in this case by negative 3. So I'm going to say z is equal to a positive 3. So here, when I did that, oh, can't really read that. I did row 2 and row 3 to eliminate the y, and it's telling me that I'm going to get my z. And I did get my z. So I have z is equal to 3. That makes me happy. So if I'm going back over here and I want to write a system, my first row equation hasn't changed at all. I'm just going to copy down the second equation. And then in the third equation, I'm going to write z is equal to 3, because I just found out that z was equal to 3. Following this pattern, I'm going to now do row 3 and row 2 to find z. Or to eliminate the z to find y. I said that wrong. So I'm looking at these two. I'm looking at, oh, why do I pick bad highlighting colors? I'm looking at row 2 and row 3. I wanted to eliminate the z, and that'll tell me what y is. So to do that, looks like I just have to add them. It's really that simple in this case. So I'm just going to take row 2, which is negative 3y minus z is equal to negative 9. And I'm going to add row 3, which is z is equal to 3. And when I add those, I get negative 3y is equal to negative 9. So I am going to divide both of them by negative 3. Uh-oh. Oh, I knew I made a mistake. Thank you. Negative 9 plus 3 is negative 6. Divide both sides by negative 3, and y is equal to 2. It's divided by negative. So now I know that z is equal to 3. I know y is equal to 2. And now I have to find x. So to find x, I'm going to have to do two things. The first thing I'm going to do is I'm going to do row 3 and row 1 to eliminate my z, and that's going to give me a new row 1. So it's telling me here, I'll just write down the first one again. So it's telling me to do row 3 and row 1 to eliminate the z. So I think what, and it's going to give me a new R1. So I think what I'll do is I will leave row 1 alone. So row 1, I'm just going to copy down and do x plus y plus z is equal to 6. And then I'm going to have to do the opposite of row 3 so that the z's will be eliminated. So negative z is equal to negative 3. And when I add those two, I'm going to have x plus y is equal to 3. And that would be my new row 2. I'm not going to write it down to be perfectly honest because now I'm going to do row 2 and row 1 to eliminate my y to find my x. So I have x. This is my new row 1 right now. My row 2 is this. So I'm doing this. And my new row 1 to eliminate my y. Looks like I'm just going to take the opposite of row 2. Messy, messy, messy. And I'm going to have negative y is equal to negative 2, multiplying that whole thing by negative. I'm going to get x is equal to 1. So I'm going to say x is equal to 1, y is equal to 2, z is equal to 3. That would be my reduced row echelon. My order pair is 1, 2, and 3. That's my reduced row echelon, actually. Now, the big question I get is once I had this C, could I have just done back substitution? Yes, you could have. And you'd still get the same thing. But that's not following the pattern, so, you know. Okay, the next one, solve the system of linear and check the solution algebraically. So when I look at this, I notice that I don't have an x in row 1. So in order for me to follow this chart correctly, I'm going to have an x in row 1. So I'm just going to pick either row 3 or row 2 and just completely switch the entire row. So let's say I take these two and I just switch the places. So now my row 1 is going to be 3x, 3y is equal to 9. You have to bring the entire thing. Whoops, didn't leave a space for my z. My bad. Now I'm going to make this row 1 my new row 2. So all I did is I just picked them up and switched them. And as long as I bring everything along with me, that's perfectly legitimate to do. So now I can follow this pattern. It says row 1 and row 2 to eliminate the x. So row 1 and row 2 to eliminate the x. Well, the x is already eliminated, so I can skip that step. Now I want to do row 1 and row 3 to eliminate the x. So I'm looking at row 1 and row 3, and I want to eliminate the x. So I'm doing elimination. I want the x's to drop out. So what I'm probably going to do is multiply row 1 by 2. So 2 times row 1. 2 times row 1, which will be 6x plus 6y is equal to 18. And then I'm probably going to do negative 3 times row 3. That way they'll be opposites. And this will be negative 6x plus 9z is equal to, and I'm multiplying by negative 3, so negative 36. And when I do that, the x's will drop out, and I'm left with 6y plus 9z is equal to negative 18. And that's going to be my new row 3. So now I'm going to write this system over again with my row 1, my row 2. Those two I have not changed at all. They have not changed this entire problem. Now I'm going to write my new row 3, which is 6y plus 9z is equal to negative 18. Then following that pattern, I'm going to do row 2 and row 3 to eliminate my y and to find my z. So looking at 2 and 3, I decide that I'm going to leave row 2 alone. So 6y plus 4z is equal to negative 18. I'm going to take the opposite of row 3. So negative 6y minus 9z is equal to a positive 18. And when I do that, the y's will equal 0. I'm left with negative 5z is equal to 0. Divide both sides by whatever this coefficient is. So in this case, it's negative 5. And I'm going to get z is equal to 0. So now what I have is I have 3x plus 3y is equal to 9. My second equation, and I'll put a little bracket around this, is 6y plus 4z is equal to negative 18, and then z is equal to 0. Now at this point I can do back substitution, or I can do row 2 and row 3. So if I take negative 4 times row, which is substitution, 4 times row 3, so that would be 4z is equal to 0. Actually, I need to make that negative 4z is equal to 0. And then row 2 is 6y plus 4z is equal to negative 18. So 6y is equal to negative 18. Y is equal to negative 3. So now I have 3x plus 3y is equal to 9. Y is equal to negative 3. Z is equal to 0. If you're following the chart, the next thing it tells you to do is row 1 and row 3 to eliminate the z. But when I look in row 1, I don't have a z, so I can skip that step. It's already done. I don't need to do it. Now I'm going to do row 1 and row 2 to eliminate the y. So to do that, I'm going to take negative 3 times row 2. Negative 3 times row 2, so that would be negative 3y is equal to positive 9. And then add it to row 1, which is 3x plus 3y is equal to positive 9. I'm going to have 3x, the y's will equal 0, is equal to 18. X, when I divide both sides by 3, is 6. So I have x is equal to 6, y is equal to negative 3, z is equal to 0. My order triplet is 6, negative 3, and 0. The most important thing is you make sure that you do go in a certain order. You're conscious of what you're doing. If you're not, then you're going to like constantly go into these loops and never be able to get out. Number 21. 21, I'm going to do row 1 and row 2 to eliminate my x. I'm going to be perfectly honest. When I look at this, because I know what's coming along later on, I switch these two. If I can have a lead coefficient of 1 for my x, I'm going to do it every single time. So I just rewrote the row 1 and row 2. And most of you probably didn't do that, but I'm doing it, so you can't stop me. So, and then 2x minus 3y. Then I'm going to follow everything, and you'll have most of the work the same that I'm going to do. I'm going to take negative 3 times row 1, so negative 3x minus 3y plus 6z is equal to negative 9. I'm going to add it to row 2. This will eliminate the x. The first thing I'm going to do is eliminate the x in every single row except for row 1. So this will be 0 and then negative 5y plus 10z is equal to negative 8. So I'm writing a new system, I'm keeping row 1 the same. That's going to be my new row 2. Now I'm going to follow the pattern. I'm going to do row 1 and row 2 to eliminate the x. So I'm going to multiply row 1 by a negative 2. Negative 2 times row 1. So it'll be negative 2x minus 2y plus 4z is equal to negative 6. Now I'm going to add it to row 3 to eliminate the x. Remember, I want the x's to go in every equation except for the first one. And when I do this, that'll equal 0. So this will be negative 5y plus 10z is equal to positive 2. Oopsie. And this should be a z. Now, following the pattern, I should do row 2 and row 3 to eliminate my y. So I'm going to eliminate my y, it looks like I can multiply row 2 by a negative sign. So this will be a positive 5y minus 10z is equal to a positive 8. And then copying down row 3, negative 5y plus 10z is equal to 2. When I add these, the y is equal to 0. The z's also drop out, so I'm going to have 0 is equal to, and when I add these two, I get 10. Well, that's not true. That's a false statement. So since this is false, that means there are no solutions. So I'm stopping right now. There's no solutions. I cannot solve it. In other words, there is no place where these three will ever equal the same thing. So there are no solutions. Moving on to 24, I am going to follow that same pattern that I've been doing over and over and over again. I am going to do row 1 plus row 2 to eliminate my x. So that's an easy one. Let's say I leave row 1 alone. So 2x, let's multiply it by negative sign because I always change the first one. Okay, I changed. Yeah. Minus row 1, so this will be negative 2x minus y minus 3z is equal to negative 1. I'm going to add row 2, which is 2x plus 6y plus 8z is equal to 3. When I add these, the x is equal to 0, so this will be 5y plus 5z is equal to a positive 2. So row 1 is staying row 1. That has not changed. Row 2 is now 5y plus 5z is equal to 2. Now I'm going to multiply row 1 by negative 3 because I want to eliminate this with this. So that'll make that a negative 6. So negative 6x minus 3y minus 9z is equal to negative 3. I'm going to add row 3, which is 6x plus 8y plus 18z is equal to 5. I have not changed that one at all. And when I add, I get 5y plus 9z is equal to 2. So 5y plus 9z is equal to 2. So then when I do this one, now I've done that, so I have a new row 2, have a new row 3. The next thing is to do 2 and 3 to eliminate the y and find my z. So in order to eliminate the y, it looks like I just have to multiply one of them by a negative. So let's multiply row 2 by a negative. So make that negative 5y minus 5z is equal to negative 2. Row 3 is 5y plus 9z is equal to a positive 2. And when I do that, I get 4z is equal to 0. At this point, I'm going to divide and get z is equal to 0. So recapping, I have row 1, which I have not touched at all yet. It has stayed the same through this entire problem. There was my row 2, and now I have z is equal to 0. Ooh, I'm going to get a fraction. All right, so now I'm going to do row 2 and row 3 to eliminate the z and to find my y. So I have to multiply this z by negative 5 to eliminate it. So I'm going to do negative 5 times row 3. So that'll be negative 5z is equal to 0, because 0 times anything is 0. And then row 2 is 5y plus 5z is equal to 2, just copying that down. I end up with 5y is equal to 2, which means y is equal to 2/5. Oh my gosh, it's a fraction, and it's okay. So I have 2x plus y plus 3z is equal to 1. I have y is equal to 2/5, and I have z is equal to, no, is equal to 0. Yeah, I did that right. But I kind of, all right, so I'm going to leave it like that. Then the next thing in my pattern says I'm going to combine row 1 and row 3. So I'm going to highlight this for you. I'm doing row 1 and row 3 to eliminate the z. So it looks like I have to multiply row 3 by negative 3. So negative 3 times row 3. So negative 3 times row 3. And I know it's 0, but I'm still going through the process. It's equal to 0. Row 1 is going to be 2x plus y plus 3z is equal to 1. When I add them, I'm going to get 2x plus y, and then these will cancel. It's equal to 1. So technically what I have is y is equal to 1. I have y is equal to 2/5, and I have z is equal to 0. That's where I am right now. Last thing I'm going to do is I'm going to combine row 1 and row 2 to eliminate the y. And when I do that, I will find a new equation 1, which will be my x. So I'm going to find x at this point. So when I do that, it looks like I just have to multiply row 2 by negative. Oh, I said row 2 and I put negative 2 there. That's not what I want. Row 2 by negative. So that'll be negative y is equal to negative 2/5. And row 1 is 2x plus y is equal to positive 1. So when I do that, I'm going to have 2x. Those will equal 0. And then negative 2/5 plus a positive 1, you're probably doing on your calculators, 3/5. Divide both sides by 2, which is the same thing as multiplying by 1/2. And I get x is equal to 3/10. So my order triplet, so x is equal to 3/10, y is equal to 2/5, z is equal to 0. My order triplet is 3/10, 2/5, and 0. Okay, going on to do the next one. Number 27. Same process, same pattern. I'm going to do 1 and 2 to eliminate the x. So it looks like I have to multiply this by negative 2. So I'm going to take negative 2 times row 1. So negative 2x plus 2y minus 4z is equal to negative 12. The biggest mistake you're going to make is with negatives. So what I like to do a double check. Here I'm multiplying by negative. I used to go positive, negative, positive, positive. If I'm changing the sign, those should all change. So I'm going negative, positive, negative, negative. So here I had 3 positive, 1 negative. Here I have 3 negative, 1 positive. So I did appear to do that right. I mean, you have to double check your work, because you will get fractions, and that's okay, because sometimes the fractions are the answers. So I don't know what to tell you. So here I'm adding these two, and when I add these two, I get 3y minus 3z is equal to negative 9. So row 1 is this, has not changed, exactly the same. Row 2, I'm writing down like this. Now I'm going to try and eliminate this x here, so I'm just going to take a negative 1 times my row 1. So that'll be negative x plus y minus 2z is equal to negative 6. Copying down my row 3, which is x plus y plus z is equal to 2. And when I copy those down, when I add those, the x is equal 0, and I get 2y minus z is equal to negative 4. So now that is where I'm standing right now. That's my equivalent system. Now I'm going to do row 1 and row 2 and row 3 to eliminate my y and find my z. So what do I have to multiply by in order that these two drop out or equal 0? I'm going to multiply row 2. I'm going to multiply row 2 by a negative 2. So that'll be negative 6y plus 6z is equal to 18. So I want yes. And now I am going to multiply row 3 by a positive 3r so that they have opposite signs. So this will be 6y minus 12z is equal to negative 12. And when I do that, I get, what do I get? I get negative 6z is equal to, I think I made a mistake. Hold the presses. Okay, I found my mistake. My bad. When I copied this over, this is 2y. When I copied this one over, this is 2y minus z is equal to negative 4. So this is 2y minus z is equal to negative 4. I put a 4 in there. Don't know why I did that. My bad. So now when I put a 3 in here, this will be negative 3. Okay, at least I caught it. That's good. And I'll show you a trick one day. Remind me to check it on your calculator so you know if you made a mistake. So I'm going to 3z is equal to 6. And I'm going to get z is equal to a positive 2. So, and I divide both sides by 3 to get that. So now I have x minus y plus 2z is equal to 6. 3y minus 3z is equal to negative 9. And then finally, z is equal to 2. Next thing it tells me to do is to combine row 2 and row 3 so that the z is eliminated. And I would then find y. So I am going to eliminate this z. I'm going to multiply row 3 by a positive 3. So I'm going to take 3 times row 3, and now be 3z is equal to 6. Copying down row 2, that's 3y minus 3z is equal to negative 9. When I combine, add, I'm going to have 3y. The z's will drop out, and this is equal to a negative 3. Divide both sides by 3, and y is equal to negative 1. So what I have now is I have x minus y plus 2z is equal to 6. Y is equal to negative 1. Z is equal to 2. Now I want to, according to the directions, I'm going to do row 1, and row 3 to eliminate the z. So it looks like I'm going to have to multiply row 3 by a negative 2. So row 3 by negative 2. Actually, can I bring that down? I can. So that'll end up being negative 2z is equal to negative 4. And now I'm writing row 1, which is x minus y plus 2z is equal to 6. When I add, I'm going to have x minus y. The z's will drop out, and this is equal to a positive 2. And I now want to add row 1, which is that x minus y is equal to 2, y is equal to negative 1, z is equal to 2. I now want to I want to do row 1 and row 2 to eliminate my y. So it looks like I just have to add those two together. So I'm going to do row 2. I'm just going to go in the order that I would. Row 2 is y is equal to negative 1. And then row 1 would be x minus y is equal to 2. So I'm going to get x is equal to 1. So my order triplet would be 1, negative 1, and 2. Okay, number 33. Same process. I'm going to do row 1 and row 2 to eliminate the x. So row 1 is x plus 4z is equal to 1. Row 2, I'm going to multiply that by the opposite, I guess. I'm going to have negative x minus y minus 10z is equal to negative 10. When I do that, I'm going to have negative y minus 6z is equal to negative 9. Now, I have an awful lot of negative signs there, and I could, if I wanted to save myself some grief later on, is divide everything in this by negative 1. And I can do that at any point. Like if I recognize they all had a 3 in common or whatever, I could simplify it. So this is going to be y plus 6 is equal to 9. So I'm going to write that down for my new equation too, if you don't mind. If you didn't divide that out, that's fine. You're still going to get the same answers. I just didn't want to work with all the negatives. So that's my second equation. Now I'm going to do row 1 and row 3 to eliminate the x. To eliminate the x, it looks like I'm going to have to multiply row 1 by a negative 2. So negative 2 times row 1 will be negative 2x. There is no y. Minus 8z is equal to negative 2. And then row 3 is going to be 2x minus y plus 2z is equal to negative 5. Notice how I kept a column for my y's so I would not smush them together. So my x's will drop out and I have negative y minus 6z is equal to negative 7. Now, you're probably thinking, is she going to divide that out by a negative? I probably would, except for I noticed that it's going to be the opposite of this y. So I'm going to leave it. So now the next thing I'm going to do is I'm going to do row 2 and row 3 to eliminate the y's. So if I look at that, they're already opposites. That I left them like that. So row 2 is y plus 6z is equal to 9. Row 3 is negative y minus 6z is equal to negative 7. When I add those, I'm going to get 0. The y's are gone. The z's are gone. Uh-oh. And this is equal to positive 2. That is not true. So there are no solutions to this one. As soon as I get no solutions, I'm done and I move on to the next one, which is an application problem. So this one, it tells me that in exercises A3 to 86, an object moving vertically is given the heights at specific times. Find the position equation, and they give you that equation. S is equal to 1/2 a t squared plus v sub 0 t plus s sub 0 for the object. And then they give me 3 points, and they have to give me 3 points because I'm looking for the a, the v sub 0, which is the initial velocity, and the s sub 0, which is the initial position. So I have 3 things that I'm looking for, so they have to give me 3 points so I can come up with 3 equations. So what I'm going to do is I'm going to substitute what I know into this equation here. I'm going to shrink this a little bit. So they're telling me S, well, for here, I'll do, this one is blue. S, well, S is 128. So I'm going to say 128 is equal to 1/2 a, and then t squared. Well, they're telling me t is 1, so this will be 1 squared, plus v sub 0 times t, which is 1, plus s sub 0. So when I square the 1 and multiply it by 1/2 and all that, I'm going to end up with 128 is equal to 1/2 a plus v sub 0 plus s sub 0. And if you don't like the subscripts, you can drop them. And I'm probably going to encourage you to do that and just write 120 1/2 a plus v plus s. That's my first equation. Now I'm going to go to the second equation and do the exact same thing. So this time they're telling me my s is 80. So I'm going to say 80 is equal to 1/2 a. And then they're telling me my t is 2. So this is going to be 2 squared plus v sub 0 times 2 plus s sub 0. So I'm going to have 80 is equal to, well, 2 squared is 4. 4 times 1/2 is 2. So this will be 2a plus 2v plus s. Remember, I'm dropping my subscripts. So that is my second equation. And I'm going to write them all together in a second. And then my third equation, doing the same thing, my position is 0 is equal to 1/2 a. My t is 3 seconds, so I'm going to put 3 squared plus v sub 0 times t, which is 3, plus s sub 0. 3 squared is 9. 9 times 1/2, I'm going to write as 9 halves. You can write 4.5 if you want. Plus 3v plus s. Remember, I'm dropping my subscripts. And then you are used to having your variables first and your equations second, so I'm going to follow that pattern, and I'm going to write my three equations. So I'm going to have 1/2 a plus v plus s is equal to 128. That's my first equation. My second equation is 2a plus 2v plus s is equal to 80. That was my second equation. And my third equation is going to be 9 halves a plus 3v plus s is equal to 0. And that's my third equation. This is my system that I need to solve. I'm still following the same pattern. I'm going to do equation 1 and equation 2, but instead of eliminating the x, I'm going to eliminate the a. I'm still going in columns from left to right. I'm going to follow that rule. So in order to do this, what I'm going to do is, in order to eliminate the a, I decide I'm going to have, what do I have to multiply 1/2 by to get 2? And I have to multiply by 4. So I'm going to multiply row 1 by a -4. That way they will be opposite. So going really slow, 4 times row 1 will be -2a minus 4v minus 4s. And then 128 times -4 will be -512. Row 2 is going to be 2a plus 2v plus s is equal to 80. And when I add those, the a's will drop out. I'm left with -2v minus 3s is equal to -432. So following the same pattern that I did before, the first equation is going to stay the same. This is going to be my new second equation. Now I'm going to ask myself, what do I have to multiply? What do I have to multiply 1/2 by to eliminate 9 halves? And I decide I have to multiply by -9. So I'm going to multiply row 1. I'm going to do row 1 times -9. -9 times row 1. And when I do that, I'm going to have -9 halves a minus 9v minus 9s. And when I multiply that 128, I'm going to have -1,152. Then I'm going to have 9 halves a plus 3v plus s is equal to 0. Those will drop out. The 9 halves will equal 0. And I'm going to be left with -6v minus 8s is equal to -1152. Now here's what I'm talking about. I didn't do it, so I'm not going to do it. But I could, since these are all negative even, I could divide it by -2 and have 3v plus 4s is equal to 576, I think. But I didn't do it, so I'm not going to do it because I don't want to make a mistake. So I'm going to write this down as my new equation 3. Following the same pattern, I'm going to look at row 2 and row 3. And I want to eliminate the v, which would have been the y. And I decide in order to do that, I'm going to multiply row 2 by -3. So row 2 by -3. So I'm going to do -3 times row 2. And when I do that, I'm going to have 6v plus 9s. And then when I multiply that, I get 1,296, all positive because they were all negative before, so all positive. Row 3 is -6v minus 8s is equal to negative 1152. And then I get s is equal to 144. So remember that's actually s sub 0. So s is equal to 144. You know, and this one, this is what I have right now. Oopsie, that's a minus. And I could do the whole reduced row echelon, but I'm not going to. I am just, at this point, since I have the S, I am going to do back substitution. We're going to just remember back substitution. And I am going to take this 144 and put it in here. So I'm going to have negative 2v minus 3 times 144 is equal to negative 432. And I'm going to solve. So when I do this, I'm going to have negative 2v minus 432 is equal to negative 432. I add 432 to both sides, which will be 0, so v is equal to 0. And then my last one, I'm going to substitute in that 0 here, the 144 here. So I'm going to write that over here, if you don't mind. So I'm going to have 1/2 a, and then my v was 0, my s was 144 is equal to 128. So when I subtract 144, I'm going to get a negative 16. Multiply both sides by 2, and I get a to be a negative 32. So I have my a, I have my s, I have my v, but I am not done. I'm going back to this original equation up here, and I have to substitute all that back in. So I'm going to say s is equal to 1/2. A, I just said was negative 32 t squared plus my initial velocity, which I believe my v was 0, so this will be 0 times t plus my initial position, which was 144. When I clean this up, when I take negative 32 times 1/2, I get negative 16t squared. This will be 0 plus 144, and that is my position equation for this particular function. Okay, almost there. So this one, and find the equation of the parabola. Again, we're going to be looking for the A, the B, and the C. So I need to have 3 ordered points because I have 3 unknowns, the A, the B, and the C. I'm going to do back substitution just like I did before. I'm going to follow this pattern till I find my Z. And then once I find my Z, I'm going to do back substitution. So here's my point 0, 3. Remember, this is your X. This is your Y. You're substituting them back in here. So 3y is equal to ax squared plus bx plus c. So when I do all this, I'm going to have 3 is equal to c. Well, that's a bonus because I know what c is equal to. All right, the next equation I'm going to do, let's do y. So this is x and y for my second equation. So y is equal to ax squared plus bx plus c. So this is going to be 4 is equal to a plus b plus c. And then the last one I'm going to do is going to be y, which is 3, is equal to a x squared plus bx plus c. So this is 3 is equal to, well, 2 squared is 4, so this will be 4a plus 2b plus c. So now I'm going to write them the way I'm going to have a plus b plus c is equal to 4. I decided to use that one first. Then I'm going to have 4a plus 2b plus c is equal to 3. So that's the second equation. And then my last equation, I'm going to have c is equal to 3. I'm still going to follow the same pattern that I did before. I'm going to do row 1 and row 2 to eliminate my a. So when I'm looking at eliminating my a, it looks like I'm going to have to multiply row 1 by a negative 1. So I'm sorry, negative 4. So I'm going to do negative 4 times row 1. So this will be negative 4a minus 4b minus 4c is equal to negative 16. Here's row 2, which is 4a plus 2b plus c is equal to 3. Add them, and I'm going to have negative 2b minus 3c is equal to negative 13. So I have my first equation, which has 3 unknowns, my new second equation, which has 2 unknowns, and then my third equation, which tells me what c is equal to. Oh, it's only 3. What c is equal to. So I'm going to use back substitution. I'm going to take this 3 and put it here and find b. So I'm going to do negative 2b minus 3 times 3 is equal to negative 13. So negative 2b minus 9 is equal to negative 13. Negative 2b is equal to negative 4. B is equal to 2. So my b is equal to 2. And then I am going to find my x by substituting, or my a by substituting in here. So I'm going to do a plus b, which I just said was 2, plus c, which I just said was 3, is equal to 4. And when I do that, I get a plus 5 is equal to 4. A is equal to negative 1. Now going back to that equation, y is equal to ax squared plus bx plus c, substituting what I know, y is equal to negative 1 times x squared plus 2x plus c, which was 3. And I would probably just write it as negative x squared. Either one of those is fine. Okay. The next one, same idea, except for I don't think I have a c. I think I have to work a little bit harder for this one. So this is x and y. So I'm going to say 0 is equal to a 2 squared plus b times x plus c. So this is 0 is equal to 4a plus 2b plus c. Doing the second equation, I'm going to say negative 1 is equal to a times 3 squared plus b times x plus c. So this is negative 1 is equal to 9a plus 3b plus c. And the last one, I'm going to have 0, that's my y, is equal to a times 4 squared plus b times 4 plus c. So this is 0 is equal to 16a plus 4b plus c. And it doesn't matter the order that I write them in. So let's just say 4a plus 2b plus c is equal to 0. 9a plus 3b plus c is equal to negative 1. And then 16a plus 4b plus c is equal to 0. Okie dokie. So if I want to do this one, I want to eliminate my a first. So to eliminate this a, I'm probably going to have to multiply row 1 by negative 9 and row 2 by a positive 4, or vice versa. Okay, let's do it that way. So I am going to do negative 9 times row 1. So this will be negative 36a minus 18b minus 4c is equal to 0. Then I'm going to multiply 4 times row 2. So that'll be 36a plus 12b plus 4c is equal to negative 4. And when I add those, I get, what do I get? I get 0 there. I get negative 6b. Do the c's drop out too? Looks like they do. No, they don't. I made a boo-boo. Oh, that's a 9. So this will be negative 5c. Okay, that looks about right. And now, so that is, I'm going to leave row 1 alone. So 4a plus 2b plus c is equal to 0. This is my new row. Now I'm going to do row 1. and row 3 to eliminate the a. So I'm going to multiply row 1 by a negative 4. Yeah, negative 4 times row 1. So that'll be negative 16a minus 8b minus 4c. That's still equal to 0. And then row 3 is 16a. Don't have to change that one at all. 4b plus c is equal to 0. And when I add those, I get negative 4b minus 3c. And that's equal to 0. Okay. So negative 4b minus 3c is equal to 0. So that's what I have right now. I decide that, I don't decide, I'm following the pattern. I'm going to do 2 and 3 to eliminate 2 and 3 to eliminate the b, or whatever in the second column. I decide that I'm going to make one 12 and one negative 12. I'm going to multiply the first one by a positive 2. Okay. So 2, oh, bad, bad, bad. 2 times row 2, so this will be negative 12b minus 10c is equal to negative 8. And then row 3, I'm going to have to multiply by negative 3, so it becomes a positive 12. So this will be 12b plus 9c, and that's equal to 0. So this will end up being negative c. Negative c is equal to negative 8, so c is equal to 8. So this is what I have. And c is equal to 8. Now I'm going to do back substitution. So I'm going to do negative 6b minus 5 times 8 is equal to negative 4. So this is negative 6b minus 40 is equal to negative 4. So negative 6b add 40 would be 36. b is equal to negative 6. Then going back to the last one, I'm going to have 4a plus 2b, which I just said was negative 6, plus c, which I said was 8, and I believe that's equal to 0. That is equal to 0. Here, let's, oh, whoa, I don't know what happened there. I just sort of want to create a little space there. So this is 4a minus 12 plus 8 is equal to 0. So 4a minus 4 is equal to 0. 4a is equal to 4. A is equal to 1. So remember the equation is y is equal to ax squared plus bx plus c. So y is equal to 1a, so just x squared, minus 6, because that's my b, x, and then my c was 8 plus 8, and that is my equation. Remember, you have to have that equation. That is the final answer. Okay, 2 more and then we're done. Borrowing, a small corporation borrows $1 million to expand its line of toys. Some of the money was borrowed at 8%, 10%, and 12%. How much was borrowed at each rate if the annual interest rate was $97,200 and the amount borrowed at 8% was 2 times the amount borrowed at 10%? Remember, I have 3 things I'm looking for. I'm going to say X is the amount at 10%. Y will be the amount of money that I borrow at, oh, should have done 8% first. 8%, then 10%, then 12%. Doesn't matter. Once you've set the variable, it'll work itself out. And Z will be the amount at 12%. 3 unknowns, 3 equations. The first one I'm always going to do is the amount of money that I borrow, because that's the one that makes most sense to me. I borrow some money at 8%. I borrow some money at 10%. I borrow some money at 12%. This is all the money that I borrowed, and I borrowed $1 million. So I'm going to set that equal to $1 million. Then I pay interest. The annual interest is $97,000. Well, to figure out interest, I take the percentage and multiply it by the amount of money that I borrow. So my second equation is going to deal with interest. So I'm going to do 0.8x, because remember you have to change the percents to decimals, plus 0.10y plus 0.12z, and that's equal to the amount of interest, which is 97,200. I have 2 equations. That's great. I need a third equation because I have 3 unknowns, and that's the last one. It says the amount borrowed at 8% which is X, was 2 times the amount borrowed at 10%, which is Y. So X is equal to 2 times Y. The amount borrowed at 8% was 2 times the amount borrowed by Y. So X is equal to 2Y. So now there's nothing that says how I have to solve these. If I'm given this precious gift, and this is a gift, this is a great gift, I'm given this guy right here, which means I can simplify this problem so much faster. I really don't want to write 3 equations. I'm going to go back, and every place that I see an X, whoops, yes, every place I see an X, I am going to put in that 2Y. And then I've knocked it down from 3 unknowns to 2 unknowns, which is so much easier to solve. So I am going to do that right now. That is a gift. I appreciate that gift. So in place of this X, I'm going to put 2Y. So I'm going to have 2Y plus Y plus Z is equal to 1 million. So that's going to simplify to 3Y plus Z is equal to $1 million. My other equation, I'm doing 0.08. In place of that X, I'm writing 2Y plus 0.10y plus 0.12z, and that's equal to the 97,200. So when I multiply these two, I get 0.16y and then when I combine my like terms, I'm going to have 0.26y. Whoopsie, that's a 7. 97,000. So there are my 2 equations, my 2 unknowns. I think I get to choose. I'm going to write this down here. And then I think what I decided to do is I decided to do elimination. And I thought, well, I could try and eliminate the y's, but why when I can eliminate the z's? If I multiply the z's by a negative 0.12, then these two would be opposite and they would go away. So that's what I'm going to do. So when I multiply this, it'll be negative point. Oh, that's just point. That's, yeah. This is negative. See, sometimes I get so excited and I write all this stuff down and don't recognize what's what. So this is 0.26. Now I'm multiplying by a negative 0.12. So this will be a negative 0.36y minus 0.12z. And then this negative 0.12 times 1 million will be a negative $120,000. So now when I add these two, the z's will equal 0, and I'm going to be left with negative 0.1y. That's probably what your calculator is going to give you. Is equal to negative 228. Divide both sides, and I get y is equal to $228,000. And it's dollars, and that's going to be the amount that's borrowed at 10%. Now I know that x is equal to twice that. So I'm going to say x is equal to 2 times that 228,000. And when I do that, I get 456,000 is the amount that I'm borrowing at 8%. And then to find the final amount, I'm probably going to add these two and subtract it from 1 million. And when I do that, I end up with 316,000. And so you have to tell me how much is it. Like if I write a table like this is great. I know that this is the amount of 8%, 10%, and 12%. You have to tell me how much is that each percent. Okay, the last one's a little football problem. So, of course, I had to put this on here because it was this Pittsburgh Steelers beating the Seattle Seahawks. So I have this football game on February 5th, 2006, and Pittsburgh wins 21-10. And then they want me to figure out. Now I know I can Google and look up how many touchdowns there were, but that's not the point. The point is trying to figure out how to do the problem. So I have 3 types of scoring plays. I am going to say X is going to be my touchdowns, and touchdowns are worth 6 points. Then Y are going to be my field goals. and those field goals are going to be 3 points. And then the final type of scoring that they had in this particular game is going to be the extra point, which we call Z, and that is 1 point. So the first thing I see is it says that the score was 21 to 10. Well, if the score was 21 to 10, that means I had a total of 31 points scored. So if I take 6 points times the number of touchdowns, plus 3 points times the number of field goals, plus 1 point times the number of extra points, I should have a total of 31. Then it says there were a total of 9 scoring plays by both teams, which means the touchdowns plus the field goals plus the extra points was equal to 9. Then it says the number of touchdowns, which is X, the number of touchdowns scored was 4 times the number of field goals. So the number of touchdowns was equal to 4 times the number of field goals. Now I could stop there because I have my 3 equations, 3 unknowns, but I'm going to keep on reading. It says the number of extra points scored was equal to the number of touchdowns. So the number of touchdowns was equal to the number of extra points scored. So that's what I have. I only need 3. If you try and use 4, you're probably going to mess yourself up. So you're just going to pick which ones you want to use. And I think that what I chose to do is I chose to use this guy, X is equal to Z, and substitute that in and then solve. So I eliminated one of my variables. So if I do that, I think I put this, every place I saw a Z, I put an X. That's what and then I'm probably going to use these 2 and not that one. Doesn't matter. So when I do that, I'm going to have 6x plus 3y, and then in place of that Z, I'm going to write x is equal to 31. So I'm going to simplify that to 7x plus 3y is equal to 31. That's one equation. My other equation I'm going to have is x plus y plus z, which I'm calling x, is equal to 9. Those are the scoring plays. So I'm going to have 2x plus y is equal to 9. So my 2 equations are 7x plus 3y is equal to 31, and 2x plus y is equal to 9. Now, I get to choose how I want to solve this. I don't necessarily have to, do row 1, follow that pattern to eliminate the x or whatever. I think it's going to be easier to multiply this by -3 to eliminate the y's. So when I do that, I'm going to have -6x minus 3y is equal to -27. Copying down this equation, that's going to be 7x plus 3y is equal to 31. When I do that, I get x is equal to 4. So that means that I have 4 touchdowns. The number of touchdowns was equal to the number of extra points, which means I had 4 extra points. And then they tell me that the number of touchdowns is equal to 4 times y. So I could say 4 is equal to